Hello students. So now we shall see the next part of organometallic compounds, that is metal olefin complex, that is alkene complexes. These are pi bonded organometallic complexes. Olefins are two electron ligands, that is you can understand by this, that is a bidentate ligand, bidentate type of ligand. Ethylene, propylene and a number of other olefins form well defined complexes with palladium 2, platinum 2, mercury 2, copper 1 and silver 1 salts. That means Roman numbers which are given in the bracket are nothing oxidation states of the respective metals. So now coming to the structure and bonding, the platinum complex, that is P2Cl2 CH4, is a dimer as shown by freezing point depression measurements in benzene and has a bridge structure with the trans arrangement of two ethylene molecules. So it is a bridged structure of dimer. X-ray examination of anion of Z salt shows that, so below is the structure of that Z salt anion. Platinum atom is at the center of the square plane. Platinum atom is at center of square plane with chlorine atoms at each of three corners. So in this below structure you can see ethylene, here ethylene is attached to the some square plane. Now we have to understand platinum is at the center with three chlorine at the three corners. Ethylene is at the fourth corner but perpendicular to the plane with center of a double bond in the plane. But so you can see here platinum is in the middle with three chlorine atoms. Fourth corner, if it is chlorine then it is nothing but it has become a tetrachloroplatinum, but the fourth corner is attached here is ethylene group. That is ethylene group is attached to the center of the double bond. So indeed the carbon-carbon double bond of ethylene is perpendicular to the expected normal metal ligand bond axis. The two carbon atoms are equidistant from the metal. So this is you can see clearly in the given structure of anion. So now you can see the bonding in case of olefin complexes can be explained by considering bond formation in ethylene complex with platinum. This is also nothing but an example of Z salt anion. So here they are given three stages: A, stage A, stage B, stage C. That is how bonding in ethylene complex with the platinum ion happens. So as we already know, we in ethylene molecule, that is C2H4, carbon is there are two carbons, each carbon bonded to the double bond, and carbon is bonded to the two hydrogen atoms. Each carbon is bonded to the two hydrogen atoms with single bonds. So in ethylene molecule, two pz orbitals on two carbon atoms. So this is with respect to the figure A given. In ethylene molecule, two pz orbitals on two carbon atoms overlap to form pi bonding and pi star antibonding molecular orbitals. Pi bonding molecular orbital is filled while pi star antibonding molecular orbital is vacant. So this is with respect to the structure A. So if you come to the structure B, the filled, now we have to understand what is going to happen in the next two cases. So now we shall describe it with two separate figures, how filled bonding pi molecular orbital and vacant anti-bonding pi molecular orbital bonds with the metal. In second stage, the filled bonding pi molecular orbital of ethylene molecule overlaps with the empty dsp hybrid orbital on platinum ion and forms ethylene platinum overlap. That is, this is called a sigma overlap. So filled pi bonding molecular orbital of ethylene molecule overlaps with the empty dsp2 hybrid orbital on platinum. So this gives rise to a sigma overlap. Platinum bonds with the pi molecular orbital, that is filled molecular orbital of ethylene and empty orbital of dsp2 orbital of metal is always empty, they will have vacant orbitals, and ligands will have always a filled orb. They donate electrons to the metal, and this is a common process of bonding happening in case of any bonds. Ligand donate electrons to the metal and forms a sigma overlap. So now in the third case, what happens here is the empty pi star antibonding molecular orbital of ethylene molecule. Here empty pi star antibonding molecular orbital. Now you have to understand here the ligand itself is almost it is empty. There is no donation of electrons from ligand to the metal. Empty pi star antibonding molecular orbital of ethylene molecule overlaps with the filled dp hybrid orbital on metal platinum ion. So right here metal is filled and ligand is vacant. In the second case, it is an usual case. Ligand is filled, metal orbitals or hybrid orbitals are vacant. But in the third case, metal orbitals are filled, but ligand orbitals are vacant. So this type of overlap gives d pi p pi bonding. So right. So this is what we call back donation. That is back bonding or back donation. That is metal donate electrons to the carbon, and this is we call as a pi type of overlap. So all the three stages. So what we see here is donation, as well as first they forms filled bonding and vacant antibonding bimolecular orbitals. So in second stage a usual bonding happens, that is empty hybrid orbitals of metal overlaps with the filled bonding bimolecular orbital. But in third case, a reverse case happens, that is back donation, filled dp orbital orbital, that is metal orbital is filled, and pi molecule, that is ligand orbitals are vacant. Here donation of electrons happens from the metal to the ligand. This is called what we call a back bonding or back donation. The two processes, the donation of pi bonding electrons of the olefin to the metal, that is alkene ligand to the metal sigma orbital, and back donation of electrons from the metal to the anti-bonding orbitals of the olefin, that is alkene C2H4, are synergically related and weaken the pi bonding in the olefin. And in all cases except the anion of Z salt, there is a marked increase in carbon-carbon bond length. Owing to the lengthening of carbon-carbon bond, carbon-carbon double bond decreases in the metal olefin complexes as compared with the free ligand by 60 to 150 per centimeter square. So this is regarding the metal olefin complexes.